Okay, here goes. So we're looking at the results in weights and biases from our massive run, and I'm going to open the evals so we can compare the eval loss with the training loss over here. Let's do this. Okay. Give you a second to take it in, but I'm sure you've seen the only chart here that we want to see. It's this one right here. Let's look at this side by side. Wow, what are we seeing here? Okay, there's a lot to take in. The first thing to note is that we have, first up, we've seen this little spike in eval loss that happened early on, and I'm going to explain that in a minute. But then we see some nice performance of the eval loss clearly coming down a lot. It comes down to 1.24 when it began at 1.27. So it came all the way, sorry, not 1.24. Yeah, 1.124. I mean, I was stopping myself there. That wouldn't be so impressive. Well, 1.124 when it began at 1.27. So that is quite a big drop. That seems to be like a significant improvement. But then, wow, what happened here? It just suddenly got massively worse, back almost to where we began. The eval loss jumped up and then it stayed about static here. And look at that. Look at how, where I hover my mouse, it shows the chart below what happened. This moment when it went from the lowest possible loss after 6,200 steps at 1.123, it jumped up to 1.283 the next step, or the next couple of steps. And that was when it began epoch number 3. So this is absolutely the key sign of overfitting. Happening beautifully. We're seeing it so clear. And this is why, this is what I missed last year when I didn't track eval loss. And I saw it when I then went to run the tests later. I saw that my model was losing performance, but I couldn't tell exactly when it happened. Of course, I could guess that it was happening at the same time as this sudden drop down, but I didn't have the evidence. Here we have the evidence. We've caught you red-handed. We've caught our model. Here it is, overfitting on the third epoch. It's suddenly the performance gets worse. And you can see it was starting to trail off. We weren't getting such good results, and then bam. So this is the magic of using a platform like Weights and Biases to really dig in and see. It shows us that we were productive for 2 epochs, and then suddenly we got worse. And yeah, that is fascinating. And because we've been saving as we go, we've been saving along. We've saved after 6,000 batch steps. That means that we know which batch step to pick in our results in Hugging Face so that we have the best possible results. We want the one after 6,200. That's our best case right there. And then we definitely don't want 6,400. Yeah, that is really powerful, really great to see this. And hopefully you appreciate this, and you've seen what's going on. And I mentioned I would say a few words about what happened here when eval loss spiked up. Well, if we take a look over here at the learning rate, you can see if you look at the chart on the bottom left that this is when the learning rate was at its absolute peak. It had warmed up and it was hitting our model with really big learning rate, the biggest it ever got to. And my guess is what we were seeing there was this business of jumping out of local minimums, of global minimums even. And so the learning rate was too high. And so our model wasn't training properly. It was just bouncing around. And that's why the loss flew up for a little bit. But then the learning rate got more manageable and we started to see learning. So I wouldn't worry about this, but it might be a sign that maybe my highest learning rate point was just a hair too high, and we might do better having a smaller number than that. But it didn't seem to affect too much. Things got back on track. But the real learning point here is that we see that a couple of epochs were productive and the third epoch was not. And it's not clear that we even need to do a third epoch. It might not be possible. But if you wanted to try and get more juice out of this, then you would want to try and research, how can we do better? How can we avoid overfitting on the third epoch? And there are many ways to go about doing that with hyperparameters. The most obvious one, of course, is to take dropout. I told you that's what dropout's all about. I chose a dropout of 10%. You could try 20%. You might be able to get the same kind of performance here. although it wouldn't do quite as well. Presumably it would be a little bit behind, but it might then be able to keep training and get to a better point after 3 epochs because dropout is higher, resulting in less overfitting. But maybe not. There's no way to find out other than to experiment. And there are other things that you can do to try and do this. One of them might be, you could argue maybe my R is too high and maybe I've targeted too many target modules. So I've given the model too much flexibility, allowing it to start overfitting. So there might be tricks to try and reduce the amount of flexibility I've given the model. Maybe I went too far. But doing 2 epochs and getting results is still pretty good. So I'm fine with this for now. But definitely the challenge for you is going to be to dig in and see if you can't optimize the hyperparameters, see if you can't do even better than this lowest eval loss, again, for 6200, that's funny, isn't it? It's an easy number to remember, 1.12345. That is the loss for you to beat. That does appear to be my lowest eval loss. So if you can do better than 1.12345, then you have beaten me, at least when it comes to eval loss for this data set. And of course, what we really want to know is what is the actual test performance on this. Okay, so those are the results. The next thing I want to talk about is generally hyperparameter optimization and comparing different runs. So we're looking here at the results of this batch that ran a couple of days ago. But what we can do, if you look up here, the breadcrumbs, you can see that there's my user account. It should have your name, projects, price, and then these runs. And I can click back on price. And what I get to see is all the runs that I have done on this test. And you can see that I've been going a bit crazy with this. So how does this work? So what you're seeing is you're seeing all of the charts together in one place. And over here on the left, you get to choose as I click here and I click on and off, I can turn on and off different charts over on the right, because if you show everything, it can start to get really busy. Here are all my different runs that I've been running. Let's take out some of them so it's not too crazy. This one here, main, is the one we were just looking at now. When you hover over a run on the left, I'm overexcited, so I'm not explaining myself well. On the left here are the names of all of the runs that you've done. On the right are the same charts we saw before, but it's got all of the graphs superimposed. Also when I hover on a run on the left, it highlights that chart on the right. And when I turn on and off the I symbol here, it shows or hides one of the runs. This one here called main that I'm hovering over now is the one we were just looking at. And that you can see is actually the best results that I got. You can see eval loss on the right there. The lowest number I got was for the run I just showed you. That is my best, even though it slams up and starts overfitting. You can see I've got another one that does pretty well. Not that one. One of them, it's one of these here, I think. There it is. It's this one. Also does quite well, but it doesn't do any better, I don't think. All of these start to overfit pretty quickly. This one actually did quite well after the first. Let's have a look at this one. Let's see what the eval loss turned out to be. It turned out to be 1.13, so slightly higher. Still not my best run. My best run is the one that we were just looking at, this one here that I've called main. So this is where you run your experiments. You're not an engineer, you're a scientist. You're putting on your science hat. You're running different experiments, experimenting with hyperparameters, try different batch size. You can see this high LR, low LR is when I tried a lower learning rate and a higher learning rate to see how that affected the results. And it turned out the learning rate I picked was the best one. And if you're wondering, wow, Ed, you're really great at this. How did you pick the best learning rate as one of the earliest runs you've done? Well, first of all, I've deleted a bunch of things that were failed experiments. But also, remember, I did all of this last year. And so I've already had a whole bash at making the right learning rate. So I was starting from the best that I had last year. And this is a whole lot more. Turned out that what I got to last year is pretty much still the best hyperparameters for most things. Anyway, the trick is to come in here, experiment, do lots of tests, try things out, try some batches with smaller batch size, which will then have lots more steps. That's why they go longer. If I take the one out, then we'll see a bit more of all of our charts. And then look at everything together. Use this as your way. Look at these training losses. Look at you can really see how it's very much not the case that a good training loss is going to be a good eval loss. Why it's so important to measure your eval. Use this as your way to experiment, test your experiments, and find the best model for the task.